Hello, everybody. This is another episode of the China Manufacturing Decoded podcast. This is episode 182, and I'm your host today. I'm Renaud Anjoran, and Andrew Amirnovin is also with me. Hey, Andrew, how's everything going?
Doing well, Renaud. Thank you very much. Good to be here.
All right. Yeah, so today we're talking about using reliability data and how to use these data to save money and to make better products. Right? So the first question really is, what kind of reliability data can we get our hands on? For example, if I'm going to launch a new product, it's the first time I work in that product category. I don't know anything about, reliability data, but is it supposed to work 1 year, 2 years, 3 years? On average, what kind of issues are most typical on that kind of product? Is it hopeless, or are there ways for me to know a little bit more and to have some expectations?
No, I think this what you have discussed right now. It's an important issue, extremely important issue, and I think that most companies, let's say, if they're equipped with the right kind of a team, design team, reliability teams, and they probably exercise exactly what we're going to discuss, utilizing the historical data before designing a new product. And historical
Mm.
data could be anything, right? Between you and I mean, we've seen plenty of return data from
Mhm.
customers, from the field. These are products that have failed for some reason or another, and they have been returned back to company. And then, of course, there are a lot of historical data related to design, like specifications, components that failed during the design and development, testing, reliability
Right,
testing, that
right.
maybe
Yes.
they tried to qualify a product but actually failed, and they have
Mhm.
reasons why it failed and how they fixed it. How about issue tracking database, for example, during the design and
Yes.
development? I mean, I you and I have seen this happen all the time. Some companies do really good job in issue tracking and some companies don't. But all of these really come back to becoming a historical data that can be extremely useful for or
Mhm.
the development.
Right, right, right. Yeah, so the fact that it's the first time you work on a certain product category doesn't mean you have no data. If you've been designing and developing the product, you've been making prototypes, you've been testing the prototypes, you have some data. And if you have been following a proper reliability program, and you've subjected the prototypes to the right types of reliability tests, then you definitely have some data from the test results, right?
Yeah,
Right.
absolutely. I think if you have, for example, some kind of milestone system like EVT, DVT, and PVT, you
Mhm.
probably have done at least four types of reliability tests. Maybe you've done engineering evaluation on some components. Maybe you've done initial reliability testing on your first proto, second proto, and
Mm.
third. And these data are extremely valuable for
Mm.
the next project, because if the two projects are sharing anything in common, like some parts or functionality or features, that means that pretty much can be tested almost similarly. And that means that the issues found in the previous product could be extremely valuable in terms of cutting costs, in terms of making the product more reliable, in terms of cutting engineering time. Why do they have to go back and make the same mistakes where they
Mm.
could just look at the previous product and not do those, right, and make a
Right.
better.
Oh, totally.
Yeah,
Totally.
exactly.
Totally. There's a lot to learn, right? Now, if a company's been selling a certain type of product to a certain type of user for, let's say, for years, they should have some kind of database of product issues, right? Often they call it product defect, but I don't
Right.
like. So it's more like, yeah, product issues or customer complaints or whatever they call it,
Right.
right? And and very often, I mean, in big companies, there's usually people who do that full time. Is they
Right.
receive, they get the samples back, they send them maybe to the factory or to after sale or repair center or whatever, and then they look at it and they try to classify. And a big deal is actually to classify it the right way. Um, so all of that leads to having a pretty good database of past issues.
Oh yeah, you're talking about like, for example, and I think that also relates to kind of like returns, right? When you have massive returns coming from the field, you have to triage those, and when you triage them, you're gonna have all kinds of lessons learned. You're gonna find out that there were mistakes done in either, for example, software updates, and or there was, for example, part of the shipment actually had used a certain vendor, right, that didn't do well in the field, but then the rest of the shipment was using certain parts from a different vendor that actually did well.
Mm,
So, from all this is all data, right? And it means that, for example,
mm,
here now we're trying to develop a new product. Don't use the vendor that didn't do well in the field, right? That's like one piece of information that is critical for having better yields, for example, in the production, or better yield, better customer satisfaction in the field.
mhm.
So if we're just talking about that one single part, imagine how many other parts, and imagine how many other lessons learned out there in the
Mm.
databases within the company, within the development team, that all we need to do is be able to utilize all that information and make sure that maybe just within one meeting with the team and understanding, okay, here's the product we're building. What is it that we need to make sure, from lessons learned point of view, from past history of
Mhm.
products that we designed or similar product that we're trying to design, so that we can actually utilize the data and make it a better reliability testing, better design, better quality, better everything. So
Mm.
that way we can actually save a lot of money. So utilizing reliability data in that fashion, is very
Yeah,
important.
and and usually, what kind of data would be saved that way, right? So if I receive, I don't know, I sell, a certain gadget, and then I receive some of the samples back with maybe a description from the user, or maybe sometimes, even better, like a video of how it doesn't work well. Well, I'm going to say what part of the product doesn't work well or doesn't work at all. And is it like a hard failure? Or maybe it's pretty obvious this one component right here, like it broke or something, versus a soft failure where, oh, if you just reset it or you restart it, it keeps working again, right? And you try to assign a cause. And and often I think quality people like to say, whatever, it's a design issue, and then maybe, a manufacturing fault also will say, oh, you picked the wrong component, versus maybe design people will say, oh, this is a manufacturing problem, right? So there's um there's a lot of important information in there.
A lot of finger pointing. I agree with you.
Yeah.
I think that issue tracking is wonderful, but most often what happens is that engineers and designers or development team are so busy that half the time they kind of like put in like one or two word, resolution. They say, yeah, okay, it was this component fixed. That's it, fixed. And that could be an issue itself, because how it was fixed is the critical information, then the data that the next person who is looking for that issue needs to learn. And the next engineer developing and working on the design of the new product, new version of that product, let's say, he needs to know, well, you fixed it, but how did you really fix it? What did you do? And so a little bit of detail is very important. I agree with you.
Yes, all the way to even in a manufacturing. Let's say the product did not pass a test and it went to be repaired. Okay. if we have this information that this product was repaired and now it's failing reliability wise, in the field, maybe it's related, right? What kind of repair? Why did it fail the test and why did it go into repair and what was done on it when it was repaired, right? So, more information is always better, basically. I think that's the easy conclusion here.
Totally agree. And I think that, of course, manufacturing is a little bit different than the development, but a lot of the issues that happens in the manufacturing, a lot of it comes from the development. So if development was done right, and the reliability testing actually revealed all the issues that the design had, all the issues that the components had or the supplier had, if all of those were kind of cleared up during the development by doing the proper reliability testing, by creating proper reliability test cases that actually mimicked the worst case scenarios in the field by the user, by end user, and then creating a test plan that pretty much caught all the scenarios all the worst case scenarios that could happen in the field. And if you have that sort of customized reliability test plan, then usually what would happen in the manufacturing is that you wouldn't see any more design issues or component issues. You'd have nothing but, ideally, let's say, nothing but manufacturing related issues. I know it's kind of hard to discuss that because this is really hard to manage it in that fashion. But ideally, every company should be shooting for that kind of a aim.
Yes, it takes quite a bit of work, right? Make sure that the components are going to be made, as long as it's within the tolerance and so on, everything will be fine. The process window is not too narrow, so it is reproducible in manufacturing, no problem. And that the stresses that the product are going to suffer in the field are not going to break it, as long as it's as expected. There's a lot of things that go into this, but okay. So we have sort of an overview of the types of data, reliability data, right? That a company can get for a certain product. Now, let's see how to use this data basically, right? Why is it good to have all this data? Let's look first. How can the data about reliability be used to make better products? So basically, the product has failed for such and such reasons most often, etc., etc. In these settings, you have some feedback also about the environment in which the products were used and how they were used and so on, right? So how would you manage the feedback into the product design, maybe for version 2 of the product?
Yeah, great question. Well, I think, as we discussed, if you have a really good reliability test plan and really good reliability engineering team, they can easily find and track all these failure modes, and then they can create what's called a Pareto analysis of these failures. Now, again, it depends on how many failures we're talking about. For example, returns coming from the field related to reliability, you could have a massive Pareto of failures. You could have like hundreds of, maybe even thousands of failure modes. And then Pareto analysis is an incredible tool because it would tally and put all this kind of like a distribution type of thing, but it will put it all in a manner that would show where the 20% of failures cause an 80% of the impact. And then all you have to do is fix those 20%. And then you'd have pretty much most of the issues gone. And then you'll end up, minor issues. But then going back to what you mentioned, on that 20%, you need to know and break it down what are those major issues within the 20%? Are the major issues component related, design related, manufacturing related, or supplier related? And if you can track those down and maybe do a Pareto within a Pareto, and find out, well, okay, we have so many components, and particularly one or two components are causing most of the failures. And then all you got to do is change those, replace those with a similar, what they call drop-in replacement parts, but with a better supplier, with a better part, or maybe even upgrade the part with a better than part, so that it can actually handle better voltage, better current, and maybe even handle better drop test, for example, or better soldering. Whatever that is the main issue, you can come back with a part that is better. And yes, these are all from reliability findings, for example.
When you say 20% of the problems, actually, sometimes you're just talking about 3 or 4 problems, right?
Correct,
Which can
exactly.
already represent 80% of the issues in the field and more, right?
Yes, exactly, as you said. And that's the thing. Those 3 or 4 issues can be resolved, and then 80% of the problems are resolved automatically by just fixing those 3 issues. And those three issues may not be that difficult. It could be just changing one part. It could be updating the software. It could be, changing the supplier with a more reliable part. So yeah, you're exactly right. It could be very minor, but how you go about analyzing all this data and nailing the issue is the problem. Is a lot of times a lot of companies don't have the right staff, or they have so much data. For example, I was with a company that I can't mention the name, that they had massive amount of data. We're talking thousands and thousands, maybe even million products. And they couldn't actually nail it down because the amount of data they had to crunch down, it was just massive. And some of the engineers would just give up on that. And that's not the right
Yeah.
way.
So they would do a random pick and then just analyze these ones, right? But
Yes, exactly.
otherwise you let yourself be really overwhelmed, definitely. So you can also use this feedback from the users to wonder, okay, how did we test these products, the version one, let's say, that had these common issues? Okay, how did we test it? It passed the test. Okay, maybe the test plan needs to be revised because now we learn that users might abuse or misuse the products, or use them in different environments that we did not think of, and then you make sure you design to these new specs, but you also test to these new specs, right?
Oh, what a great discussion on the user experience and field experience. Yeah, absolutely. Nowadays, with most people having access to immediately giving feedback on the product, it's amazing how much user data you can get. And like you said, user experience is most often so much different than how the product was intended to be used. Here it is, the user actually invented new way of using, and or abusing, like you said. And all of this can be fed back into the reliability data, and can be fed back into the, let's say, lessons learned database. And so that the designers that working on the new product must actually go back and look at the reliability data, look at the user experience data, look at the lessons learned database, and based on what the users are thinking and how they are going to be using the product, then the new product needs to be actually addressing all of these new features, new way of using, so the reliability engineers actually need to create appropriate test cases that actually mitigates and keeps in mind testing the user experience issues that were let's say found in the previous project. We don't want to see that in the new project.
Yeah, absolutely. Yeah, that makes sense. Now, yeah, some companies have sort of overshot the needs of their users in some cases, right? So we were talking before recording this, episode, as an example, the Mercedes cars in the 1980s, they could go on and on and on. The engines, they might go up to 500,000 kilometers or
Yeah,
more,
right,
right?
right. Very reliable.
Whereas these days, only the big truck, like the trucks like the Ram and trucks or
Right.
the Ford
Toyota Tacoma.
F-150 or
Yeah,
the- these trucks get to these types of mileage, but normal cars, including luxury cars, including today's Mercedes cars, don't come anywhere close, right? So they were probably overshooting the needs. And another example was the Nokia phones that were nearly indestructible. Some of the models could
right.
be thrown out a building,
Yeah,
fall a few floors, and
yeah.
on the floor, and still be totally okay, right? That's just amazing, right?
Yeah, I think so. I actually worked for Nokia, and I know
Hmm.
exactly what you're talking about. Some of our mobile phones those days were extremely reliable. And yes, you're right. You could. We actually did a few. We dropped them from two or second floor, third floor of a building right on the concrete, and yeah, they just bounced back. And yeah, the battery came out, but put them back together, and they worked fine. And I know what you mean. It is over engineering, over reliability, and in some cases it's important, right? If your mobile phone is your life and you
Mm.
really depend on your mobile phone, maybe that's a good thing. Having
There you go.
more reliability built into that product. On the other hand, if you have a product that is looking clunky, too much reliability, you really don't need to spend so much money on reliability. That would be also not good. It's just a waste of money making the
Mm.
product too much reliable. And in fact, what will happen is, for example, let's just say in the case of Nokia phones, people would use those phones for years and years and wouldn't buy another Nokia phone. So that's not good neither, right?
Yeah, that's that might be a problem for the company. I mean, there's certain areas, like for example, if I go into a plane, I don't want the plane to be 99% reliable. I want it to be 100%. So
Exactly.
it's one of these cases where, yeah, they add redundancy. So, or maybe there's two engines or four engines. There's a lot of things in there that have been built in, so it's highly reliable, right? This can
Right.
happen, and then this can happen, and then it will still fly because there's still this fail safe or this extra redundancy or something. They really thought about a lot of these topics, and when they do their theoretical calculations, they say, well, this might happen, but it's only one time out of a billion flights. Well, okay, maybe we don't prioritize this one. They still have a cutoff, right? Still have a way to rule out. Otherwise, you would keep adding reliability on and on and on to your products. You would never even ship the new version. You would always keep working on it because there's always a way somewhere somehow that it goes down. Yeah, this is one of these examples where you want extra reliability.
Yeah,
Or
totally agree. And same thing for medical
mm,
products, right? I mean, you don't
yes,
want
yes.
to be a 95% reliable. You probably want 99.9% or 100% if possible. I know it's impossible to make 100%, but at least you want it to be as reliable as possible. You don't want someone to die because your
Mm,
product stopped working. And so
right.
certain products are deemed to be more reliable. It's very hard to come up with an example. I think your Mercedes Benz was a good example of a product that doesn't need to be necessarily running for 500,000 miles. In fact, in 1986, I don't know how many, well, maybe in Germany, I guess. Yeah, in Germany, maybe they had amazing roads and autobahns that you could drive it forever. But in most other parts of the world, they don't have too many roads those
Mm,
days. They didn't. I mean they had, but I don't think it was necessarily people didn't drive their car
as
uh
much.
that
Mm,
much. Yes, exactly. So I think most
Really?
people drove maybe less than 10,000 miles per year, right?
Wow.
So 500,000 miles, that means,
Yeah, yeah, yeah.
yeah,
Totally overshooting the needs.
overkill a little bit.
Yeah,
Yeah.
right, right, right. Now, my question was, what kind of learnings can we get out of this data to improve products? Now, let me ask the reverse. What kind of learning can we get out of this data to cut production costs? All right. Because it's also, we don't want to necessarily over-engineer the products and make them excessively reliable. As you mentioned, if the product goes onto the market and it's twice the price that it should be, well, maybe a lot of users would prefer to get a cheaper one that is less reliable.
Definitely, once you have all this data and you review those, then you realize that, okay, there are parts in here that don't need to be necessarily that reliable, for example. And maybe you can, instead of using custom parts that are very expensive, maybe you can use standard parts that are cheaper and just as much reliability. That's one option. And one lessons learned, you can get information from the data. And of course, you can
Mm.
also find out that there are too many parts being used in order to make the product
Oh,
more
yeah. Mm.
reliable. Maybe you don't need that many parts. Maybe you just need one or two good, reliable parts, and that's good. So you can cut the number of parts that are being used. So that's two. And then, of course, you can look at your suppliers and quality of those parts. If you see you're using multiple suppliers, and when you use multiple suppliers, you're buying less parts from them, right? The volumes are low. And
Mm.
when the volumes are low, you're paying heavy price for those.
Mm.
And so all you got to do is cut down your suppliers and go with one or two suppliers. And then now you're giving them big volumes and they're giving you better price. So that's number three.
Mm.
And
Mm.
then, of
Makes
course, you
sense.
could look at some parts in your design, and you find out that that those parts are going. The design itself is obsolete. Because of times have changed, the technology. You really don't need to design it that way anymore. So you need to go with a better
Mm.
design, more DFR, design for reliability, DFX, design for excellence. And when you go that way, you find out that, maybe you don't need, you can just eliminate some parts completely. And so you actually come up with a better design, fewer parts, more quality, more reliability built into your design. And you cut a lot of costs.
Mm. Yeah, right. Let's look at an interesting example that came out here and there. Is about Ford, Henry the Ford, the grandfather, right? The one who came out
Right.
with the Model T and so on. And that's what I see even in the Wikipedia entry, but there's various articles with, different people with different takes on this story. But basically the story goes like this. Henry Ford asked some people to go and look at scrap yards, various scrap yards in the US, and basically inspect the old Model T cars and tell him, okay, what failed basically. Some of them, oh, the axle failed. This one, the brakes or the pistons failed, etc. And and to count basically the different instances, right?
Right.
And then also what parts never fail. And then
Right.
they say that, for example, the Kingpin or the king bolt, which is that part that I think is a very important part that links the front axle, I think, to the body or something like that. I mean,
Yeah, right. Right. They connect.
if it,
Yeah.
yeah, if it breaks, I mean, your car,
Out of
you can't
control.
keep riding your car. Yeah, yeah, totally.
Right.
It's actually quite unsafe if it breaks. But anyway, and they said, well, the Kingpins, they look good. They could still have been working, in the cars for years and years. Seems like they never broke. And then the conclusion from Ford was that, oh, okay, so we over-engineer them. They're too good. Let's make them to inferior specification, which is kind of
to cut
logical, right? It
costs.
makes
Cut costs.
sense. It
But the
makes
aim was
sense.
to cut costs, right?
Yes, that's a way to cut costs. Yes, because he was relentlessly trying to find ways to, to produce for the mass market to get the price down and so on and so forth. What do you think about this story?
I think it's really interesting because uh, there's two ways to think about this, right? You know, Ford was in the right direction because he's trying to cut costs. He's making millions of automobiles, and imagine you just cut $1 each. You could be saving millions of dollars, right? So I think in theory, thinking that way for every part that you can cut cost is the right way to go. On the other hand, this particular part was Kingpin, very critical part. If it breaks,
Hmm.
then you'll spend more on the legal, uh, you know, instance of these issues, trying to, or you'll be spending more on fixing the problem if this thing failed. So why would you actually make something that is reliable already a little bit, cutting corners on that? Because you try to retool that part and try to make it thinner, let's say, and maybe cut cost on that. Just the act of trying to cut cost would cost more than the part itself at the end. You have to
Right.
retool it, you have to retest it, and then you have to, add new part number, and then you have to retrain your team to use this part instead of the old part. All of this will cost more than just leave it alone and use it as is, and then try to cut costs on other parts. So that's another argument. Online I saw all kinds of articles and all kinds of engineering teams. Some were pro on one side, but most people thought it wouldn't make sense to cut corners on this kind of a critical part.
Hmm. Right, right. So it reminds me of something we discussed before, is there were the feature phones with their small screens, and they were pretty reliable. But then people started to prefer the smartphones,
Yes,
which actually broke much more easily, right? So
right.
sometimes people do prefer another form factor, or because they want some other functions, they will go for something less reliable, right? I mean, we can't ignore that.
That
It's
is
just
so
the way it
true.
is.
Yeah, I mean, the old days, let's just say it, Nokia phones were smaller phones. They were not touch screen, but all of a sudden Apple came out with touch screen phones and everybody loved it, even though you drop it from a quarter of a meter, half a meter. And even today, some of those Apple phones they will break very quickly, but people love, to use it, and they are willing to spend extra money, to put it in the case, and protect it, but have the functionality that they want. But yeah, I agree with you. People do strange things sometimes to get what they want.
Yeah, right. Well, that's why it's always a trade-off. I guess that's kind of the
Exactly.
conclusion here. Probably you would not try to save a couple of bucks on the airbags if you were selling cars, right?
Oh
Um,
yes,
and we looked at that Takata airbag recall,
the Japanese
and
supplier.
yes, the Japanese supplier, there was a big problem. I think the Toyota cars had this problem at one point, but then it turned out that a lot of different car companies, not just Toyota, buy the airbags from the same company, Takata in Japan. And I see at the end of 2022, a total of 67 million airbags have been recalled,
Oh.
and 11 million still yet to be replaced.
And a
So,
lot of people died, and a lot of people
and
got,
some people died, correct?
yes. Mhm.
Because when it inflated, it broke the housing in a way that actually projected some pieces of metal into
Yes.
people's faces.
Right.
So anyway, not fun stuff, right? So that's an example where it's better to pay a bit more to keep this risk of catastrophic failure very, very low, right? But then in some other cases, the failures would not be catastrophic. And in that case, like, yeah, okay, I broke my phone. Well, what am I going to do? Okay, I can keep using it with if it's a bit broken, or I can pay to replace, or I can accelerate the replacement of the phone,
Right.
right? I can keep this phone maybe as a backup in case the new one has some problems or gets lost. Okay, it's not a catastrophic failure. So in that case, sometimes you need to question your reliability objectives and say maybe we don't need, you know, it, maybe the product has some other ways of appealing to the customers, right? Uh,
Yeah,
mm,
you're absolutely right. I think in the case of the Takata airbags, there were a bunch of mistakes were made. Takata was
mm,
a great Japanese, very reliable product
mm,
manufacturer. They had a good history of making great airbags. Unfortunately, just like any other company, here and there, once in a while, you get a supplier that just doesn't do a good job, meaning that Takata had their own suppliers for those parts.
mm,
And one of those suppliers just missed making the quality parts and then affected the customer, and the customer
mm,
being Takata.
mm,
And that impacted everything. And then all the other automakers who had only one
mm,
supplier for that company, for that part, meaning the airbag. And having one supplier had its own risks,
mm,
because
mm,
when that happens,
sure.
all these companies, all these automakers all over the world had to do recall. And I agree
Yeah.
with you in the case
Mm,
of a mobile phone. I think that mobile phones have come in a long way. I do recall way back when there was no good internet system and no cloud where you could save
mm,
your
mm,
data. Once your phone broke, oh my God, all your data and everything was gone.
mm.
There was no backup
That's a
system.
good point. Right.
Yeah.
Then that was catastrophic at that point. But now you buy a new one, a
Yes.
new, even new Android, you just enter, okay, this is my Gmail account or my Google account, poof,
Exactly.
and then it will sync everything back in.
Sync back and everything. So it's more, yeah. So situations have changed, and it actually has improved the reliability in some ways.
Mm. Yeah, overall, correct. Because it's less about the device itself, the hardware. It's about
Right.
the whole product, which includes the cloud backup and so on. Yeah, absolutely.
But
Hmm.
all in all, it makes sense what you said. Uh, some products we need to spend more money to make it more reliable because it's necessary, because it saves lives. It helps product to be realistically reliable. But in some cases, there's no need to make it too reliable because it just wastes money and cost in terms of unnecessarily being reliable.
Right, right. And all of that, you need some data to make the right calls also. All right.
Yes.
Well, that was an interesting episode. Thanks a lot, Andrew,
Thank
for
you.
helping me cover it. And to our listeners, thanks for tuning in, and we'll be back as usual next week. And if you have a chance, please leave us a 5-star review and a comment. We like to see those. Maybe in Apple Podcasts or wherever you're listening to podcasts. Talk to you next time.
Thanks again for listening to this podcast, brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.